Hello, I'm Teacher Melai, and let's talk about one group pretest post-test design. So the topic is the effect of blended learning and the performance of the students in mathematics. So assuming that we're going to use one group pretest post-test design, so it means that before performing the intervention, you will give the student pretest first for the initial diagnostic of or for the initial knowledge of the students. And then after that, perform the intervention. And after performing the intervention, you're going to give them post test. So, what will be the questions, for example, if you have that set up? So, first, of course, you need to ask the question what is the performance of the students before and after the intervention? Then, after that, the most important is asking the question is there a significant difference between the pretest and post-test in mathematics. Because of course, if you're going to compare now the pretest and the post-test, and you will find that there is a significant difference, then that's the time you can conclude that there is an effect. Or if it's the same, then there's no effect at all. So let us consider an example for this using a dummy data. So this is the dummy data. But the data here includes scores in algebra, geometry, and statistics. So they are given pre-test and they are also given post-test. But the pre-test given is parallel to the post-test, or rather the post-test is parallel to the pre-test. So we call the students as the subject of the study because the design is experiment. So they are not just merely a respondent, but subjects of the study. So first, we need to compute for the pre-test score. So by adding the scores in algebra, geometry, and statistics. So each of the item here is equivalent to a perfect score of 10 points, so which means the perfect score is 30. So to compute for that, we will just encode the formula equal sign sum, open parenthesis, and select the scores of the students for algebra, geometry, and stat, close parenthesis, and click OK. So if you're done entering your formula, all you need to do is to drag it. So you have to drag it until to the last score, the score of the student number 30. So this is the pre-test score. While for the post-test score, so let us also compute for this. So equal sign, sum, open parenthesis, select the scores, close parenthesis, and drag it until respondent, it's a subject number 30. So let's go back to that. Okay, so it's here. Now we have here an option performance, or rather, it can be that the performance depends on the person's score, or it can also depend on the actual score. So that is based on your research methodology. If later you're going to state there that, for instance, if the score is 1 to 5, it means that the performance is very poor. 6 to 15, and all other possibilities. Or it can be that you're going to consider the percent score, wherein if the score is from 0 to 20%, it means the performance is poor, until 80 to 100%, the performance is excellent. Okay, so assuming that you considered the percent score, so let us also place here percent score. I place 2 for the post and just retain percent score 1 for the pretest performance. So to compute for the percent score, of course, we just need to, again, to place the equation or the formula for this. The score in the pretest over, this is out of 30, multiplied by 100. And then just drag again your cell here until to the last respondent or subject rather. Okay, so next, let us also consider this. So let's just also compute for the percent score over 30 multiplied by 100 and drag it until to the last subject or to subject number 30. So in our previous video last time, we presented how to show the answer for the performance of the students in mathematics. And you can just go back to that video to see how to present it. But at this time, what you need to do is to present the pretest before and also the pretest after. So instead of considering it just one table, or you can actually combine it so that it you can see side by side what is the improvement later in the scores. Okay, so next, the next thing that you need to do is our concern, of course, is to answer problem number 2. So you can use, so let us just set this into 2 decimal places. So it's your option later what software to use. If you want to use the Microsoft Excel, or if you have other softwares like SPSS, then you can also do that. Okay, let's go back to our problem. So the problem is there a significant difference between the pretest and post-test in mathematics? So this is just as basic, we just need to apply basic statistics here, particularly in two groups, two dependent groups, and that is t-test for independent sample. So you can use t-test for independent sample if, of course, our data is normally distributed. So you also need, of course, to check if you satisfy the conditions. But based on our data, so let us go back again. So since we have a 30 number of respondents, so by central limit theorem, so you are for sure familiar with that theorem. By central limit theorem, it states that since we have at least 30 number of respondents, it's a comparison of two groups. However, these two groups are dependent from each other because the same group took the pretest, and of course, they also are the ones who took the post-test. So basically, we have equal number of subjects for pretest and post-test. Or we will compare same numbers of scores in pretest and in post-test. So what we are going to perform here is to use the data analysis in the Microsoft Excel. So how to do that? So you just need to make sure, of course, that you have the data analysis. So data, you have here the data analysis. So you have to click that. And then let's locate for the t-test. So where is the t-test? So we have here t-test for paired two samples for mean. So you have to select that and click OK. So our variable 1, so let's consider the percent score 1. And variable 2, select as, also select now the percent score 2. That's until 30. And since let's go back. Since we selected the first row, which is the label, we have to check the labels. So then after that, it's okay that you're not going to change the setting here anymore. New worksheet apply, and then just click OK. So this is now the result of the t-test for paired samples or paired two samples for mean. So as you can see here, so you have the computed value for the mean and the variance. But if you reported in your paper that you're going to use the standard deviation, so it means that there's a need for you to get the square root of this. So let us just generate it here. Standard deviation. So let's place standard dev. So you need to just get the square root of the variance. What did I do? I just placed the formula equals SQRT, open parenthesis, the cell for variance, and then close parenthesis, then click OK. So we have the variance 7.56, and for the other one, we also have 11.01. So what you need to place later is just the value of mean. So I'll highlight it. You have to place the value of the standard deviation and also the degree of freedom, P is statistics. And let's consider that two-tailed test result. So this is the value of probability. Okay, so let us interpret this. So as we can see in the table, percent score is the post-test. So the performance of the students after the intervention is higher than the performance in their pretest. So it's 67, and then for pretest, it's 45. So let us also check if there is a significant difference by looking at the value of, you can look at the value of the T statistics here. So why is the result a negative value? It is just, of course, simply because in our formula, it involves the mean in the pretest and mean in the post-test. So which means that the formula used here is that we have the pretest minus the post-test. So obviously, there is a higher value in the post-test. That's why the value in the t-stat is negative. And then for the critical value, two-tailed, it's 2.04. We are also aware, so let us consider Microsoft Excel to do that. Paint, I mean. Okay, let us consider Paint for us to review this. So how will we know that our variable is, or rather our result is significant or not? So assuming that this is our normally distributed table, so we have the value of P. So look at this value. It's T.04, which means that these values are, it's two-tailed. So this is the negative 2.045, and this is the positive 2.045. Now, the T statistics value is negative 7.71, but it does not mean that since it's negative, we are referring on the left side. So as mentioned, the reason here is because I entered the pretest first before the post-test. But in manual computation, the usual method is that you have to deduct post-test minus the pretest. So it means that post-test is higher than the pretest. So this is actually, it can be an absolute value of 7.71, or it's just a matter of placing it in our formula or in our Microsoft Excel. So which means negative, or rather positive 7.716 is on this side. So it's on the right side. So which means that if our t-value falls within this in between negative 2.05 to positive 2.05, we are, this is the acceptance region, we are accepting HO, while if the value is beyond this, we are, so these are the rejection region, these two sides. It's a rejection region. So which means that we are rejecting the HO. And there is a significant difference. Or if we're going to look at the value of the P, the probability value, so the area here is actually, so we have a negative 0.08. So we have to move it. So we have 0.000. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 6, 5. So let's just double check it. So 1, 2, 3, 4, 5, 6, 7, 8. So this is actually the probability value. This one. This is the equivalent value. So this is 1.65 times 10 raised to a negative 8. So the probability is very small. And that is within this part. So let us shade this part. It's this one. This is the probability value. So it means that there is a significant difference, and the post-test is significantly higher than the pre-test. So for interpreting our data, you can use APA format so that you can present now the one highlighted here. So what we just need to place the mean, the standard deviation, the t statistics value, the degree of freedom. Anyway, just to review you, the formula for the degree of freedom is n minus 1. So since the number of subject is 30, so 30 minus 1 is equal to 29. So as mentioned, you can place or transfer your values here in Microsoft Word and follow the APA format. And it is already your option if you want to add more problems, like if you want to consider if the performance before and after in algebra is also significantly higher in statistics and all other areas that you want to consider. But what I am trying to tell you is that the main reason why you just need to use this is for you to compare the pretest and the post-test. So in the post-test problem, we are just focused in the overall performance. So if you have question, feel free to, of course, to PM me, to message me. Thank you for watching.